All right, chapter 10, respiratory system. Now, for the respiratory system and then the next chapter, digestive system, I'm trying to show you some figures of the actual anatomy and talk you through the material by using more pictures, because all the words, you can read all the words in your textbook, and I want to make sure that you're getting that a visual image of what's going on in these systems. So let's go ahead and move ahead. All right, respiratory system. Probably already know what it does. It brings in oxygen and it rids the body of carbon dioxide. So we call these processes of bringing in oxygen inspiration or inhalation, and it's essentially air moving from the atmosphere outside of your body into the lungs through a series of cavities and tubes. Expiration or exhalation is really just the opposite. The air is going to move from the lungs, back up those tubes and cavities, and then out to the atmosphere. The act of breathing, so in and out, is called ventilation. So that's the inhalation, exhalation, or if you like the words inspiration, expiration, then you can use those instead. So let's take a quick look. Now, typically in human respiration, we are breathing in through our nose. Okay, a very important thing happens when we breathe through our nose, and that's that essentially the air is becoming warm and humidified. So we're moistening that air so that it's not essentially going to be drying out our respiratory tract. So we want to warm and moisten it. Also, not only in the nasal cavity, but we're going to find out later in the trachea, there's a series of essentially mechanisms to ensure that we're filtering the stuff that we're breathing in. So in your nose, you have nose hairs. They're very good at trapping materials that you might be breathing in. Sometimes you sneeze. That's a way to essentially eliminate any of those foreign particles that you might be bringing in. We also know that in our nose, if you're exposed to smoke, if you're exposed to really strong scents, what happens is your nose starts running. Why is your nose running? It's trying to expel those foreign particles that you're breathing into your nasal cavity. Typically, they tell us that we should breathe in through our nose and out through our mouth. I don't know where that got confused. I think some of us are just mouth breathers. I had braces for a really long time, and I remember my mouth was either hurting or just full of metal. And back when they wrapped every single tooth in a band, it was not a good time. And so sometimes we essentially learn to breathe differently because of something like that, or you might have allergies, you might have asthma, all kinds of conditions that make your nasal cavities feel very full, and you're not able to breathe very easily through your nasal cavities, so instead you breathe through your mouth. Okay, so in the event that you bring air, you breathe in through your mouth, it can dry out your mouth and the back of your throat. So if you've been mouth breathing all night, then you might wake up with a sore throat. So let's talk about the throat. The back of the throat, let me get my little cursor here, there it is called the pharynx. Okay, so this is essentially where the nasal passages meet the oral passage where it's going to descend down your neck. So this is your pharynx. The pharynx then is going to keep on descending until it meets what we call the glottis, which is essentially the vocal cords and the space between them, and that opens into your voice box. Okay, so we have the glottis, and then we have the voice box, which, you can put your pointer finger, middle finger right here in your throat, and you can feel your larynx. So anything that's the larynx and up, we call that the upper respiratory system. So if you've ever been told you have an upper respiratory infection, then it's involving any of these parts from the larynx up. If you have a lower respiratory infection, it's below the larynx. So let's take a look. So here we have the trachea. The trachea is a very well supported open tube. That tube is essentially supported by rings of cartilage. So flexible, but very supportive. So this is also what we call the windpipe. I'm reminded of wind instruments and the band. And essentially you have this nice big open tube. So air is going to pass down and pass out in inspiration and exhalation. So this trachea then is going to branch, and it's going to go into the right lungs, which have 3 lobes, and the left lungs, which have 2 lobes. You may ask yourself, Why are there only 2 lobes on the left side? That's because we need room for the heart. So you can see this space here. So we branch the trachea into the left and right lungs, and this is called the bronchus. This bronchus then can divide up as a primary bronchus, secondary bronchus, and eventually we get to some smaller tubes, and we call these the bronchioles. So you have those both in the right and left lungs. The bronchioles are eventually going to, right here you can see them, they are going to terminate or dead end in what we call the alveoli. So these are they look like clusters of grapes. And this is where we actually have the air exchange. So that's where you're going to have the oxygen being dumped off and the CO2 being released back into the sac. Now, just below the lungs is a very, very important muscle, the diaphragm. This diaphragm is made up of skeletal muscle and is going to help in ventilation. So you may have learned to control your diaphragm. If you've been teaching or presenting or acting or playing the trumpet, then you know how to control the diaphragm, or you could if you wanted to and you learned it, but you don't always do it. So we'll come back to that. So your book wants to differentiate between external respiration and internal respiration. Okay, so essentially we're thinking about how the respiratory system intersects with the cardiovascular system, which we just finished in the last chapters. And so external respiration is what is happening, the exchange of gases between the alveoli and the capillaries of the lungs. So we're going from this airspace into the capillaries. Internal respiration is when we're going all the way down to the cell level and we're dropping off that gas from the capillary to the cell and then picking up the CO2 and bringing it across. So external respiration is in the lungs, between the alveoli and the capillaries, and internal respiration is where we're actually doing the exchange between the capillaries and the cells or tissues of our bodies. Okay, so this is a revisitation of the figure from a previous chapter. I think it was chapter 5. So this is showing us all these systems that are intertwined by essentially the cardiovascular system. So here in purple, up in the upper right-hand corner, we see the respiratory system. So breathing, we are doing essentially inspiration and expiration. So this is our external exchange here. And then when we make that exchange from where do we go to the cells down here, we see the oxygen being dropped off and the CO2 being picked up. This is the internal exchange. And of course, the cardiovascular system is just acting as the transport system to transport that oxygen. And then after it picks up that CO2 to transport that CO2. Okay, so we talked about this, the nasal cavities, warming, moistening, and filtering the air that's coming into our upper respiratory tract. That air descends down the pharynx to the back of our throat. If we mouth breathe, then that certainly then is going to meet the back of the throat as well. And then it's going to descend down into the glottis and then the voice box. This is just a more detailed picture or figure of this. I don't really have much more to add, so I'm just gonna go ahead and move on. Okay, the lower respiratory system is anything below the voice box. The voice box is also known as the larynx. So we're thinking trachea, the bronchial trees, so we have the primary and secondary bronchus, then the bronchioles, and then of course that includes, or those are contained within the lungs. Remember how I said there are a couple of different areas where we are filtering the air that we're breathing in. One of those places in our nose. The other huge place are along the cells of the trachea. So the trachea has these cilia. So they have these short extensions of the plasma membrane. You can see them here. Located between them are goblet cells. And essentially, these cilia are acting to trap any foreign particles. So if you go down here, you can say, ooh, maybe this is some pollen. That's what it looks like to me. It can be a number of things that you've breathed in that's maybe irritating your trachea. So we have these goblet cells cranking out some mucus. And I think they actually also call this some kind of ciliated elevator. If you have a chronic of the back of your throat, or clearing your throat. It could actually be because you've got more essentially mucus in your trachea, and by coughing you are eliminating some of that material that has trapped along the tracheal lining. Okay, so pretty cool. Now if I'm a smoker, I can actually kill my cilia. So, and I can also make lots of mucus, but my ciliated elevator is not working as well as it should. All right, so let's take a look at the bronchial tree. So essentially what we have, remember the trachea is coming down, it's dividing up. So we have the bronchus, primary bronchus, secondary bronchus, and then we get down to these smaller tubes, the bronchioles, and then the bronchioles are going to terminate in the alveoli. So we see those there. Lungs, I think we talked about. We have 3 lobes on the right, just 2 on the left because we had to make room for the heart. Certainly the lungs are where all the action's at. We can talk about the tubes, but the actual tissue of the lungs is super important to maintaining elasticity and essentially nourishing, if you will, our bronchial tree. Now there is actually a covering to our lungs, much like there's a covering to the heart, the pericardial. Oh, my computer got mad at me because I'm out of disk space, so I had to delete some things. So we were talking about this covering to the lungs, the pleurae, singular pleura, and there's 2 layers of what we call serous membrane, and it's making serous fluid. So there's essentially an encapsulation of the lungs to help protect them. All right, we talked about the primary and secondary bronchi, but essentially what we have is a series of tubes that's getting going from a larger diameter to smaller diameter. So the smallest bronchioles is actually just 1 millimeter. And then we see that the bronchi are eventually going to terminate in the alveoli. Now the bronchi have cartilage like trachea, but as they get smaller, the cartilage disappears. Now, something to mention, it talks about an asthma attack. Now, our lungs are made up of smooth muscle. So that smooth muscle can actually affect the bronchioles, because if the smooth muscle is contracting, it can constrict those bronchioles and cause it to be hard to breathe. So a person might sound like they're wheezing. All right, so here we go. We're in our little bronchiole. We're bringing the oxygen in through inspiration, and then we get down to these air sacs. Remember how I said they look like a cluster of grapes? I literally remember that. Maybe the only thing I remember from biology from like 3rd or 4th grade, but I remember that. They look like clusters of grapes, and surrounding these clusters of grapes is, guess what, a capillary network. So here we are bringing, the low oxygen blood from the heart. So this pulmonary artery is bringing blood away from the heart to this alveolus. And essentially what's happening is it's dumping off the CO2, and then you exhale, but any free oxygen in there is going to move across into the capillaries and go back to the heart through the pulmonary vein. All right, alveoli. The alveoli is a very thin membrane. And essentially what we have is oxygen diffusing across that wall or membrane. And so that's, it's these concentration gradients where it's high concentration on one side and low concentration on the other side that's causing the gases to move in the directions that they're moving. Oxygen is high in the bloodstream but low in the alveoli. CO2 is high, I don't know what I just said. Oxygen is high in the alveoli and low in the bloodstream. CO2 is high in the bloodstream and low in the alveoli, so they essentially are going to move across that concentration gradient. Surfactant. So one of the things that's going to help the oxygen move across the alveoli membrane is essentially this lipoprotein that's surrounding the alveoli. It's keeping it open and perky, but it's also going to allow those gases to freely diffuse. Now, an infant that has respiratory distress syndrome, it's often with preemies, but essentially what we will do is we will give them surfactant replacement therapy. So essentially putting surfactant down into the trachea so that they have that. It will help pop open those alveoli and then allow for the gases to exchange more freely. All right, we will continue the next part of Chapter 10, the mechanism of breathing, in just a moment.